What's up, everyone? It's me, Miss Wesley. Time to talk polar coordinates yet again. I am so excited for today. We're starting on page 3 of the polar packet in a second. And to begin with a little lighthearted joke, what do sea monsters like to eat for a snack? They like to eat fish and chips for a snack. Looking at the top of this page, it says coordinate conversion. I just scribbled a couple sets of coordinate axes at the top. And I want to preface this lesson by saying that what we're going to do is we're going to try to create this new style of graphing back to what we know and love. So just pick a random set of rectangular coordinates, like the point 2, comma 3. Very easy to plot, right? You go over 2 on the x, up 3. You're floating, if this is point P, somewhere up in quadrant 1. Well, there should be an easy, quick way to convert this to an r, comma theta, and figure out how many rings you've come out and how much of a central angle do you need coming out from the origin, what your theta would be. The same thing should work the other way around. If I have a point like 4, comma 300 degrees, and as we learned in our new way of graphing, you're coming out 4 rings, and you're going over 300 degrees as an angle theta, right? So it's down in quadrant 4. There should be a positive x and a negative y that lands you in that exact same spot. And we actually already know everything we need to know in order to convert points between the two styles because we know our trigonometry. Couldn't wait to get back to this. It says the polar coordinates r theta and the rectangular coordinates x, y are related as follows. We know this diagram. Here is an angle, a central angle in quadrant 1 with a perpendicular drop down to the x-axis to form a right triangle. And this just makes me think of sine, cosine, and tangent. So let's use all 3 of those. Okay, so what can we use here? You're given polar coordinates, you know r and theta, and let's say first we want to try and find x. And you got to think to yourself, can you think of a trig function, either sine, cosine, or tangent? One of them is going to be perfect for relating r and theta if they're both known. I'm thinking cosine, right? Cosine of theta. We learned it in SOHCAHTOA form, right, as the ratio of the adjacent side to the hypotenuse. That's true. And in terms of the ratios of x, y, and r, cosine of theta was defined always as x over r. We've known that. This is perfect because you know these two things. X can be your only unknown, and you can easily solve for it. I'm going to get it by itself. And you've got this equation you can trust when you know r and theta. Easy way to get x. Next order of business, we got to find y. So now you have to think of another trig function for me. What's going to be a trig function that will be good for relating r and theta to y, right? Are you thinking, am I hearing you say sine? Is that what I hear? Because it's right? Sine of theta, the ratio, sine always had to do more with the y. It was the ratio of y to r. And then solve for y, you get y equals r sine of theta. Okay, I want to practice with these facts to see if we could do these odds down the left-hand side converting to rectangular form just without a calculator, just from what we know about sine and cosine. You're given an r and a theta. Let's say we want to find x first. Well, it should be as simple as plugging into this fact that we just wrote here. X equals 3 cosine 45 degrees. Could it be this quick? Well, 3. I think back to my handy-dandy unit circle, my exact values, and it's square root of 2 over 2 would be the cosine of 45 degrees. So x coordinate, 3 square root of 2 over 2. Y coordinate, you know what? Something tells me it might be very similar. R sine of theta, so 3 sine of 45 degrees. And the sine and cosine of 45 degrees happen to be the exact same value, so your exact value here of the y is also 3 square root of 2 over 2. Believe it or not, that's all it takes. If your question was presented to you in the format of an ordered pair, you need to give your answer as an ordered pair. So you've converted this to rectangular form, and the coordinates are 3 square root of 2 over 2, comma, 3 square root of 2 over 2, as x and y, like that. Could we check our answer and make sure we're not completely off base, like we've landed in the completely wrong quadrant? Absolutely. 3 comma 45 degrees, what quadrant's that in? You're out 3 rings, and you're 45 degrees up as a central angle. This is great. In Q1, right, you've gone precisely up and over the same amount, and we landed with a positive x and a positive y. All right, go ahead, try 9. I guess I'll just go from the same definitions. I'll try this one the same way. X is going to be r cos theta. So you have r and theta, negative 3 cosine of 2 pi over 3. And y is going to be negative 3 times the sine of 2 pi over 3. think of 2 pi over 3, right? We've got to get an exact value for its sine and its cosine. It is, if you think back to quadrant 1 of your unit circle, and I know you guys know this, it's just been a little while, pi over 3 was the coordinate in quadrant 1, or the set of coordinates in quadrant 1, where you're going over a little less than you're coming up, right? 1/2 was the x. Square root of 3 over 2 is going to help us with the sine, the y. And we're over in quadrant 2, where I think A, S, T, C, right? All of them are positive here. Only sine and its reciprocal are positive in quadrant 2, so that makes the cosine negative. Let's say our x-coordinate is, whoops, that should be a half. Negative 3 times negative a half. From an exact value, you get 1 1/2, or 3/2. For negative 3 times the sine of 2 pi over 3, sine is going to be the y-coordinate, and we're in a quadrant where the sign is positive. Positive square root of 3 over 2 should do the trick. And then you have your y-coordinate, and to be thorough about it, I'll list it as an ordered pair. So your x, comma, your y. Did we want to land in, okay, so you're over positive on the x, negative on the y. We landed in quadrant 4, it looks like. Does the original also land in Q4? It should. You're coming out 3 rings. So 1, 2, 3, right? You're going over 2 pi over 3 is up here in quadrant 2, but check out your negative radius. That flips you down to quadrant 4, where we did land. Positive x-coordinate, negative y-coordinate. We know we're in the right quadrant. 11. I wonder if you could think of 2 ways to do 11. I'm going to try it the same way we did 9 and 7, but I wonder if this is a quick way or if I'm just being duped here into doing more work than I need to. 5 cosine of pi, right? X is r cos theta. Y should be r sine theta. So 5 sine of pi. Well, these are quadrantal, so I think of my unit circle over at pi, where the coordinates are going to be what? Negative 1 comma 0, if I want the sine and the cosine. So negative 1 comma 0. The cosine is negative 1, so I get x coordinates negative 5, and the sine is 0. 5 times 0 gives me 0. So I pretty much, I don't think I did anything wrong. The answer should be negative 5 comma 0, but I'm wondering if I could have guessed that just by graphing it off the bat. If I graph this easy set of polar coordinates, you're going out 5 units, and you're moving an angle of pi. I usually find the angle first. So I'm going 1, 2, 3, 4, 5 this way, plot my dot. I know and trust that that is going to be at negative 5, 0. Without showing any of this work, a quick picture of a quadrantal angle can get you straight to the answer. Okay, I know what you're thinking. You're thinking, Miss Wesley, great, we can convert rectangular or polar to rectangular. What if things are the other way around? Is it just as quick? Now notice, for that one way of converting, we utilize sine and cosine. I don't know how useful they're going to be for rectangular to polar, but let's think back to this same exact picture. Let's say that first we want to get r. So here's a case where you have x and y. You want to get r and theta. What is an equation that you know of that relates r to x and y? Because we know x and y, we want to get r. It's actually good old Pythagorean Theorem. Pythagoras comes to save the day again. So it's going to be r squared equals x squared plus y squared. That should match up with a true Pythagorean Theorem definition that works with this picture, right? The sum of the two sides squared, the legs squared, is going to equal the hypotenuse squared. So this will help you out. It's not like you're memorizing new things up in these boxes. We already knew what sine and cosine were equal to. We're just using them in a different context. We've used this all year, and you've used it your whole math career, I'm sure. So we're going to just use the Pythagorean Theorem. If we did solve for y, don't forget there's a plus or minus when you square root both sides. So we can write this with r, and I meant to say solve for r, with r isolated, r by itself. This plus or minus we will address. We'll talk about that. I'm going to just star a little note here. The picture of where the point falls, I'll put that first. So I meant to write the picture, will tell you. It's going to dictate whether to use plus or minus. We know that we have sets of polar coordinates that have positive radius values and negative radius values that flip you to the other side of the graph. So when the time comes, we'll let a picture dictate which one of those we're going to use. So getting r, Pythagorean Theorem, what else do we need? We have r, we need theta. I got to think, what is some fact that we know of, some trigonometric fact that relates x and y to the angle theta? Well, we've used sine, we've used cosine. It's time to use tangent. So tangent's going to help us get theta. The tangent of the angle theta is equal to the ratio, as it always has been, of y over x. This is the version I'm going to box. You're not memorizing something new, you're just thinking back to what you know tangent equals. If I want to get theta by itself, I can surely take the arctangent of both sides or the inverse tangent. So theta equals the angle that has a tangent of y over x. Okay, now the fun part, let's get to converting. We have the first example here, number 8, says convert to polar form. We have an x and a y, we need an r and a theta, and let's say we want to get r first. So r squared equals x squared plus y squared. We can think Pythagorean Theorem, and we'll square both of those. R squared is 1 squared plus 2 squared. And let's do the math here. R squared equals 1 plus 4. It equals 5. R in this context could either be positive or negative square root of 5. The one we end up choosing will put us in the correct quadrant for the picture, because we know there's other ways to name these same exact set of points in polar coordinates. Let's go get theta and use tangent to do that. So tangent of theta equals y over x, so 2 over 1. At this point, if it's the tangent of some exact value that you recognize, don't use the calculator. Just write for me what it is. This happens to be one that I don't have memorized, where the tangent of theta would be 2. So I will make sure not to get moded unless otherwise stated. You could get an answer in degrees or radians. I'm gonna go mode. I'll go radian mode. And I'll type in arctangent, inverse tangent of 2, enter. In radians, it's going to be roughly 1.107, and that's how I'll keep this answer. Degrees aren't wrong. It didn't say we couldn't answer in degrees. So if you type this in degree mode, just to get a sense of what quadrant you're in, 63.4 degrees is also going to be good for theta. So I will write my final answer, like I stated before, as an ordered pair. It's r comma theta. And let's get back to this plus or minus discussion. What quadrant do we want to be in? Well, the point 1, 2 is in what quadrant? 1, 2, 3, or 4? Well, 1, 2 is up in quadrant 1. Let's pick a positive radius value, square root of 5, and let's pick a quadrant 1 angle. In radians, it's going to be about 1.107, rounded. Okay, let's try a couple more. So 9 says negative 1 comma square root of 3. This is your x and your y. Let's get r first. R squared equals x squared, so negative 1 squared is 1, plus y squared, square root of 3 squared, is just going to be 3. Ooh, looks like we get a whole number. R could be plus or minus 2 in this case. Now maybe I should get smart and decide on a quadrant right now, so that can help me eventually choose that plus or minus and be cognizant of what angle I'm picking to make sure this falls in the right spot. Looks like we're in quadrant 2. You've got a negative x value and a positive y value, Q2. So I'll just keep that in the back of my mind for when I'm eventually going to write an answer for this one. Got to get theta too. Let's use tangent. So tangent of theta equals y over x. Square root of 3 will say over negative 1. Tangent equaling negative square root of 3. And I got to think for a second. There are a number of angles that have this as their tangent, and it's an exact value we should be able to come up with. So think of it as, I know I'm either leaning toward a reference angle of pi over 6 or pi over 3. I want the one where it's square root of 3 over 2 up top and 1/2 on the bottom. Because when I divide those, the 2 should cancel, and it'll leave me with the square root of 3. And I want this to be my y and that to be my x. If I go with pi over 3 as a reference angle, whoops, moving that around. Go with pi over 3 as a reference angle, that should do the trick, but I want to be in a quadrant, ASTC, where the tangent is negative. And tangent's negative in quadrants 2 and 4. So quadrant 2 would be a great answer since I plotted that original. Let's say theta equals exactly 2 pi over 3, which has a reference angle of pi over 3, or it could be 5 pi over 3 and so on. I like 2 pi over 3. I like to use that in my final answer because it leaves me in quadrant 2. So we'll say positive 2, 2 pi over 3. For the third one, maybe I should try to do it quicker. It looks quadrantal. Try sketching the third one first. So 0, negative 4 falls right down here. 4 units down this way, negative 4. This is your x and your y. Your r could be that distance from the origin down 4 units. So r could be 4. Whoops, r could be 4. Your theta is what quadrantal angle? Try 3 pi over 2. If you check this using Pythagorean theorem for r and tangent for the other, we'll get the right answer. See you next time.